All right, so this thing is stopping, and it stops in a time of 2.1 seconds. Okay, so it's also going to stop in some distance here, right? And there's some other force acting on it besides friction. So if it's sliding to the right, it's going to have a kinetic friction force acting on it, right? And the kinetic force will be acting to the left. Okay, and then there's going to be some other force acting on it here. We'll just coyly pretend we don't know which way that force is. Could be to the right, could be to the left, but the friction force is going to be, let's figure that out, right? Force of friction equals mu times the normal force. On a level surface, that's mu times m times g, right? So that is the kinetic coefficient, 0.48, right, times 22, and that's kilograms, right, times 9.81 newtons per kilogram. That's kilograms, there we go. So 0.48 times 22 times 9.81, I'm getting 103.5936. So that's this force, right? Negative 103. Okay, and then there's some unknown force. Oh, we need to figure out the rate of deceleration here. Okay, so I'm going to use v equals u plus at. Right, the final velocity is 0. Initial is 12 plus a times 2.1 seconds. That's meters per second, right? Okay, so that's going to be negative 12 divided by 2.1. Divided by 2.1. Okay, so the acceleration is negative 5.7143, we'll say. Okay, I'm just going to store that thing, baby. Okay, there we go. So now we're set. This acceleration is negative. That is, it's slowing down. If it's moving to the right and stopping, the acceleration is negative. And then we can set up our F equals ma. Right? So our forces are unknown force, friction to the left, and that's it, right? And then that equals 22 kilograms. Oh, now I've labeled, this is newtons, right? And then the acceleration is negative, the same coordinate system, right? So negative 5.7143 meters per second squared. Okay, so that times 22. I'm getting this side here. Okay, so plus 103.5936. And I get that the force equals minus 22.12 newtons, right? So the fact that it comes out negative means that that force is actually to the left. That force was actually to the left. It was actually helping it stop. Without that force, it would have taken a greater amount of time to stop, okay?